everyone. Let's talk about something I'm sure you've all run into. You're out on a job, it's a cold day, and you're just staring at your resin, willing it to cure. It's taking forever, right? It's a super common frustration. Well, today we're going to dig into the science of why that happens, and even better, how you can totally master it.
Yeah, that feeling, you've done everything by the book. The mix is perfect, the application is smooth, and then crickets. It's just sitting there, all tacky and stubborn. So why does a little drop in temperature throw such a massive wrench in the works? Well, it's all about chemistry, and we're about to break it down. Okay, so let's jump right in. When you're working with resin, you gotta understand something. Temperature isn't just some minor detail. No way. It is the biggest variable you're dealing with. It literally dictates whether your project is a success or a failure. If you can get a handle on it, you'll get solid, consistent results every single time. I don't care what the thermometer says.
So here's the science, made simple. Resin cures because of a chemical reaction, right? Polymerization. Now think of temperature as the gas pedal for that reaction. The ideal sweet spot is around 20 degrees Celsius. That's you cruising down the highway. But when it drops to 14 degrees, well, you've basically just slammed on the brakes. The whole process just slows way down. But here's a little twist. A slower reaction isn't all bad. I mean, at 14 degrees, you get what's called a longer pot life. Basically, that's your working time. So you've got more time to get the resin exactly where you want it before it starts getting thick. But, and this is a huge but, there's a major trade-off. The cure time gets way, way longer. So you're looking at more waiting around, which on a job site just means more downtime.
So if you really want to get a handle on your projects in the cold, there are two terms you absolutely have to know inside and out: pot life and cure time. They might sound kind of similar, but trust me, they're talking about two totally different parts of the whole process. All right, first up, pot life. The easiest way to think about this is it's your working time. It's that golden window of opportunity right after you mix everything together when the resin is still smooth and easy to apply. Once that window closes, boom, the resin gets too thick to do anything with. And like we just said, in the cold, that window stays open for a lot longer.
And then you've got cure time. If pot life is the sprint, cure time is the full-on marathon. This is the total time it takes for the resin to go from a liquid to a completely hardened, structurally strong final product. You know, for something like a pipelining job, this is how long that packer needs to stay inflated inside to get a perfect bond. And let me tell you, if you try to rush this step, you're looking at a complete project failure. Seriously.
Okay, so this is the absolute key takeaway, the big aha moment. Pot life and cure time, they're basically two sides of the same coin. They are directly 100% linked. So if you're out there in the cold and you want to slash that painfully long cure time, what do? The answer is simple. You have to use a more reactive resin, one that's designed to have a shorter pot life right from the start. All right, we can talk theory all day, but the numbers, man, the numbers don't lie. They really tell the story here. So let's look at some actual data, and you'll see just how insane the impact of temperature is on your timeline. This is where the rubber really meets the road. Okay, check this out. We're looking at two different resin types here, a type A and a type W, which is a winter formula. Now look at that type W at a nice 20 degrees. You get a 17-minute pot life, and it cures in 170 minutes. Not bad. But now, drop that temperature down to a chilly 5 degrees. Just look at what happens. The pot life gets a little longer, sure, but the cure time, it absolutely explodes. It jumps all the way to 330 minutes. That's 5.5 hours. Can you believe that? And this chart just makes it crystal clear. For that winter resin, just by dropping from 20 degrees down to 5, you've nearly doubled the cure time. Think about what that means for your day. That's the difference between packing up your tools in the afternoon and being stuck on site late into the night. That's the cold weather challenge, right there in one picture. Okay, so we've seen the problem. We totally get the science behind it. The big question now is, what are we going to do about it? Well, I've got you covered. Let's run through a super simple 3-step game plan so you can take back control and get your projects done on time, even when Jack Frost is nipping at your nose. Here it is, your 3-step playbook. Step 1, plan ahead. You gotta switch to a faster, more reactive resin. Grab that winter grade formula or something with an accelerator built in. Step 2, and this is a great little trick, is to control the temperature of the resin before you mix it. Keep your components warm, maybe in the truck cab at around 20 Celsius. This gives that chemical reaction a massive head start. And finally, step 3. This one's all about patience. You have to wait. Don't deflate that packer. Don't mess with the project until you've hit that full cure time. Absolutely no cutting corners here, guys. So, from now on, when you're planning a job and you see the weather forecast dipping, you'll know exactly what to do. It's not about trying to fight the cold, right? It's about working with the chemistry and making sure you've got the right stuff for the job. So I'll leave you with this. The forecast is always changing. Is your resin choice ready for it?